Hello students, in the series of NIC important problems, today we are going to discuss 5 most important problems. Fine, let's start with first problem. In first problem we have the 5 items, that is A, B, C, D and E, which are pushed into stack one after another starting from A. Okay, so what the problem says that we have a stack. Fine, in particular stack we are going to insert A, B, C, D, E. Find A, then B, then C, then D and then E. Fine. After the stack is popped, 4 items and each element is inserted in a queue. Whenever we are trying to pop any item from stack, that element will be inserted in a queue. So first, in a stack we have to pop only the top element, so we insert E, then D, then C, then B. Fine. Next, the 2 elements are deleted from the queue. So in queue, first in first out is deleted, so E is deleted, then D is deleted and pushed back into the stack. It means after deleting 4 elements from the stack, my stack has only one element, that is A. Now I have to delete first E, then D from the queue, and as well as I have to insert these elements into the stack, that is E and then D. Fine. Now one item is popped from the stack, so again I have to delete the D. The popped item is D, so correct answer is D. Are you getting my point? It is a simple problem in which first of all we have to do some operations in the stack, then we have to perform the delete operation from the stack, and simultaneously we have to insert into the queue. Fine. If you are being comfortable with the property of stack and queue, that is last in first out, first in first out, then it is a very simple problem, hardly take 30 seconds. Fine. So move on the next problem. The time required to search an element in a linked list of length n. Suppose we have a linked list of n length. Fine. We have to search an element in a linked list. So as they are not mentioned any, it is a single linked list or what, but again it may be anything. Fine. So if we want to search an element, the worst case time required is, first of all we have to go through the particular list or particular node. It means if a linked list have n node, then we have to traverse the list or the linked list one after the another. Are you getting my point? There is no random access like in array, so it requires order of n time. So right answer is order of n. Why? Because in linked list random access is not possible. Fine. If we talk about next problem, yes, a complete binary tree with the property that the value at each node, keep in mind the value at each node is at least large as the value of its children. It means the parent node is always at least large. It means suppose we have an example like 100, 90, 80, 70, 60, 50 and 40. It means parent, a complete binary tree with a property that the value of each node is as least as large than value of its children. 100 has 2 children, 90 and 80, so 100 is greater than 90 and 80. Again go for node 90. 90 is greater than its children, that is 70 and 60. 80 is greater than its children, that is 50 and 40. So 70, 60, 50 and 40 have no children. So it is a example of max heap. So it is an example of max heap. AVL tree is wrong because it is not a balanced binary search tree. Again C is wrong and A is wrong. Fine. So it is the correct answer is heap only. Now we have one more problem. Yes, suppose that the number 7518360942 are inserted in that order. It means the element are inserted in the same order. Find into an initial empty binary search tree. That point is very important. We have to insert these elements into the binary search tree. The binary search tree uses the usual ordering of natural numbers. What is the in order? First important point, keep in mind, my dear students, always the in order of BST is sorted. Keep in mind. Find the in order of BST is sorted always. Take an example of like 10, 5 and 15. What is in order? For in order, we have to first traverse the left subtree, then root, and then the right subtree. Fine. So is this node has any left subtree? Go. If this node has any left subtree, no. So print the root, that is 5. Is the node 5 has any right subtree? No. Then the node 5 is complete. Now move on 10. So left subtree of 10 is completed. Now print the root. Fine. Is there any right subtree? Yes. Now is there any left subtree of 15? No. Print the 15. Is there any right subtree of 15? No. So you can see that the in order of binary search tree, keep in mind it is for binary search tree only, it is always sorted in nature. So can you tell me which one is the sorted answer? 0, 2, 4, 3, 0, 1, 2, 3, 4, 7, and only this one, C is the correct answer. Fine. So keep in mind that the in order of binary search tree is always sorted in nature. Now next, again it's a very important problem. See, the following numbers are inserted into an empty binary search tree. So keep in mind that binary search tree topic is very important in the following order. Fine. What is the height? We have to find out the height, and it is saying that the height is the maximum distance of a leaf from the root. So first of all, we have to construct the binary search tree for these elements. So first element is 10, fine. Next is 1. So 1 is less than 10. So keep here the left hand side of the 10, 1. Next is 3. Again 3 is less than 10, move left. 3 is greater than 1, move right. Fine. Next 5, which is going to be right of 3. Next 15, right of 10. Next 12, 10. 12 is greater than 10, fine, but 12 is less than 15, fine. Next 16, move on the 10. 16 is greater than 10, fine. 16 is greater than 15, fine. So we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6 and 7. Now we have to find out the height of binary search tree, and height is maximum distance. Fine. So distance in terms of number of edges. Here we have distance of 2 in this path. In this path we have a distance of 2, but in this path 1, 2 and 3 we have a distance of 3. The correct answer is B only. Fine. So in this way, these are the most important problems which we covered, the topics stack, queue and binary search tree. If you have any problem, if you have any confusion, please write down your confusion in comment section box, and if you have still any doubt, you can reach out to NIC YourPedia module. Thank you so much.